So how I keep track of where I am in a certain process. All right. And I think this actually simplifies code a lot because it takes a lot of the logic out of like making sure the conveyor continues to move forward, right? It's like, oh, I have to latch it. I don't have to do. No, I think this simplifies this a lot. This actually kind of makes it almost more sequential. All right. So let me go ahead to my tag table. Let's just delete everything and start from scratch.
Can you record this part?
I am. So,
Okay.
are four different steps here. All right. So I've looked at my process I'm telling you guys to do. All right. And I've already determined I have four steps. All right. So what I normally will start with is I will start with creating tags for those steps. All right. So I'm going to call it step one. No, I like stages. I don't know why, but I like stage one. Boolean. All right. We're going to go ahead and make this an M bit, an address bit of, I'm going to start with 4. Just again, get me away from things I know might screw me up. And then I'm just going to drag this down until I have 4 of them. I actually made 5, but that's fine. All right. And the key here is when you're thinking about this, go back to this, is, all right, how do I know when I'm in stage 1? And I guess I actually need to create some inputs, right? So we go, what was it, goods in slash out. What else did this call it? Actually, let's get my Word file. Nope, I exited out of that. Punching photo. I guess I should add photo to this as well. All right, and I'm just going to call this I0.0. 4 of those right away. All right, and then we had limit up. Down. I guess I also need a conveyor forward, right? I need a conveyor reverse. And that should be O0.0 and, oh, sorry, Q0.1. Q0.0. All right, now that I have my tags all made. All right, and let's go ahead and make this half a screen too so we can continue to see things. There we go, nice wide screen. All right, so how do I know when I'm at stage 1? All right, and here's here's my little tricks. All right, first, let's just go ahead, and I know I normally told you guys not to do this. All right, but I'm gonna keep all of my stages together in one little network. All right, so I kind of have my stages in one network. I'm gonna have my outputs in another network, just to group things. So that way, when I'm trying to look at one specific item, I don't have to go, is that network 1, 2, 3, 4, 5, all the way to 8. All right, I'm just gonna have two networks in this case. All right, and we're gonna put a coil on the output here, except for I'm gonna make this a set. All right, and that will be stage 1. So, at what point would we say we're starting stage 1? All right, if we have to put a piece down here so it moves that way, right? So stage 1 is moving this way. When would you say that we are at stage 1?
When we're at that limit switch, right?
Not the limit switch. Close.
When that sensor is broken, that's at the very end of the conveyor.
Right, so is that a make or a break?
Shoot.
Anybody? Remember, that sensor is normally closed.
It's a make, right? Since it's normally closed. Or wait, no, it'd be a break.
It would be a break. All right. So we're at this. This is goods in. So we start stage 1 whenever we would put a piece there. All right. And I'm also going to throw a whole bunch of logic in here. In this case, and I'm going to say, what?
Real quick, because I remember getting tripped up with this in the last class. When the actual sensor itself is a break, would the code input be a make or a break?
So that is the never-ending game, Jeff. All right. It all depends on what you're trying to do. That's the end of the game here. So I call the real-world sensors normally open or normally closed. All right. And remember, I call these that we have a make, which is this, which is the not line through it, and we have a break, which is the line through it. All right. So I go back and forth with that. That way, I just keep my programming language kind of different from my real-world language when I'm talking about things to you guys. So if I say something make break, it's dealing with an actual input in the software. If I say normally open, normally closed, it's the actual sensor. So this sensor is normally closed, which means it is normally true. All right, so if I put a make in here, an open one of these, that would say, oh, that's true, and it would let power flow through. All right, I don't want power flowing through unless we put a piece in front of it. So I want this to be true when that is false. All right, which means I need to have a break here. And luckily, again, for you guys, this is something that you can test, right? Normally we can test this at least. So here's my little example for you guys. So here I have, I put stage 2, stage 3, stage 4 here. So basically the only time that stage 1 will become true is if there's a piece at the sensor and we're not already processing another piece. All right. And in this situation, that makes sense. All right. Is that we're not already processing another piece. We'll get to this, this one later this semester if this ever opens. Oh, it's behind the screen. We're going to get to this bad boy later this semester. You guys are going to complete this at the whole class. All right. I think there's, 8 of you guys or something like that. And there's a whole bunch of different things. We'll have 6 different PLCs controlling this thing. It's really what it comes down to. So, stage 1 here can't move anything to stage 2 unless stage 2 is moved back. Stage 2 can't push anything to stage 3 if there's already a piece on stage 3. However, if stage 3 has a piece on it, stage 2 is empty, stage 1 can load a piece. So, to keep this thing moving as quickly as possible, basically you can load the next stage as long as it's empty. And for this situation, since it's a continuous path, right? With the one that we're working with right now, it's not a continuous path. You put things in location 1, it moves down, and then sooner or later it comes back. So we can't preload another piece, which is why I have not stage 2, not stage 3, not stage 4 here. Now, at what point do we enter stage 2?
When that thing's broken, right?
Which
when
thing?
The sensor's broken.
This one?
Yeah.
Yep. When we.
That's the one that.
Yep. So we enter stage 2 when the punching photo sensor is true. All right. And however, there's a key here. Also, as long as stage 1 is true. This is how I do it, at least. All right. So once we put a piece here, the system's like, okay, we're in stage 1. And then the conveyor is going to move it down. Now, we haven't dealt with actually making the conveyor belt move yet. All right. We're only going to do stage 1, just so you guys know. Or stage 1, maybe stage 2. But we haven't made the conveyor belt yet. But once this piece reaches here, we're now in stage 2. All right. So at this point, we've hit that second sensor. Stage 2. Oh, we're in stage 1. Second sensor's true. We're now in stage 2. All right. So we're going to set stage 2, but we're also going to do something else. We're also, going to reset stage 1. All right, this is why I like set and reset so much. All right, is you can break things apart. All right, we don't have to latch it. We could do all sorts of nice things here. So we've stage 1 is true. We've moving that piece, removing the piece. It hits the second sensor. We're in stage 1. It resets stage 1. It sets stage 2. All right. So now, as far as system's concerned, we're in stage 2. All right. Now the compress can start coming down. All right. How do we know when we're in stage 3? So now we're in stage 2. We're coming down right now. When do we get to stage 3? Well, I'm going to leave that up to you guys to figure out. All right.
Limit switch.
Yeah. Well, based on a limit switch, and I think my code also says there's a timer involved and some other things. But I'm not going to write your whole program for you because I don't want to give you guys another solution to a whole assignment. I want you guys to actually think about things. So now if we look at our outputs here, all we have to do to make our life simple is we can say conveyor forward. Oh, I put that in the wrong place. Sorry. Let's move that. That goes over here. Boom. There's our logic for conveyor forward. We're done. All right, no latching circuit, no anything on this line to make the conveyor go forward because all of the actual logic is actually up here. All right, we don't need anything else other than stage 1 because that conveyor will only move forward when we are in stage 1. Now, there will be times, again, when we get to this other wonderful machine here. If we look really closely at this, you'll notice that the piece will come down this way Let me do a little snip and sketch again. Purple's fine. So you'll notice that we go this way, right? So that piece will get loaded on. And I break this into maybe 2 or 3 different stages just for this section, because we have a stage where that moves on, we have a stage where this thing activates, and we have a stage where this thing leaves. All right, so there's 3 different options happening on that one conveyor belt. But you'll notice that conveyor belt moves at 2 different locations, right? Stage 1 and stage 3 on this one. That means in our PLC, we would say if we're in stage 1 or, we're in stage 3. So again, your output lines are extremely simple because there's no logic actually, there's very little logic actually happening here. It's all about what stage of the process are we in. So all of your hard logic is up here, and then all your just kind of some simple logic down here by the motor. So that means down here, all we'd have to do to make the punching station move down is we'd have to do that, and then this, and then we'd have, did I create that? I don't know if I even created that tag. I didn't even create that tag. Punch down. There we go. That doesn't work. Nope. There we go. And then we would say touchdown. So here you can kind of see how at least how my brain works. All right. Latch stage 1, unlatched 1, latch 2, and depending on what stage you're in, we have different outputs getting turned on that way. All right. Could you add more logic down here? You damn well better believe it. You could have like a whole system active line, right? If we do a whole new rung here, you could have your start, a stop, an output. Let's latch this like we normally would. Start, stop, active. I know these are all mad at me because I don't actually have tags made for them. But then you could very easily just throw, okay, as long as the system is active here, we're good to go. All right. So you just have that on all your output rungs. And the glorious, depending on how you define this, is the system doesn't have to be active, and it's still keeping track of your stages, right? It's not forgetting that we've already latched something because we're in stage 1 or stage 2 or whatever. That makes your life a little bit simpler. Now you may want to have your actives up here as well, so that way you can't accidentally start the system in stage 1 if we haven't already, if the system's not already active. So a little bit of a give and take going on there. But this is how I like to keep track of things. And I find that to be a nice, easy way to be like, okay, we're doing this, then we're doing this. It's just a very progressive thing. It's, what do I do to start my first stage? What do I do to stop my first stage and move on to the next one? So it's a very focused thing. It's not like, okay. And then the glorious part about this type of system is if you do have to start a conveyor again, you don't have to come through here and go, well, I have to bypass this, right? And then, oh, I need to also bypass this, with that, which then comes all the way up here. All of a sudden now you're trying to read your code and you're like, what the hell is this thing saying? Because you've got 3 different bypasses and latches and all that craziness going on. This to me keeps it much simpler. It's for it to do stage 1, which I'm going to call conveyor forward, and you could call this conveyor forward stage, whatever you want to call it. I just like stage 1, stage 2. Maybe have a list that you keep somewhere that says stage 1 is conveyor moving forward, stage 2 is punch down, stage 3 is punch up, stage 4 is this. All right. And you guys can have a whole nother stage. You could have a stage for, if there is a timer involved, you could have a timing stage. As long as the timer's true, we're in the timing stage. All right. And that keeps you then from having to keep that timer latched, as long as you keep your stages set up right, because as soon as oftentimes you'd latch the timer with this bottom limit switch. So as soon as we move up, that timer would forget. Well, if you have that set up wrong and you don't have your code right, as soon as we move up, we forget the timer. It goes, whoa, 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 back up. And now it has to move that down again. And, all sorts of crazy things are going to happen. So this is how I like to do things. To me, it makes a lot of sense. Sometimes I'll do, wrong. Sometimes I'll do this just to keep my sets and my resets together, because that helps me out some. If you notice, when you put this up here, you get a big gap between your one set and your reset sometimes. I zoom this out, it'll really accentuate that. Oh, well, okay. well, we only have a few symbols. It, to me, causes problems because you have a reset, which is an output all the way over here on the left, but you have another output all the way here on the right. So sometimes I'll do a little or statement here, just so that way all of my outputs do stay all the way on the far right. So that is how I like to keep track of things. I'm not saying that's the best system. I'm not saying that's the only system. This is the way that I do it, and this is also one of those ways that why I can kind of code things really quickly is because all I'm ever focused on is a single step of that process at a time. I don't care about what has to happen 3 rows later. I don't have to go back and go, well, I need to modify this rung to add. No, it's just, oh, I'm in stage 3. It's a whole new rung. All right, and that means my outputs all care. And by doing it this way, it becomes a very sequential program because stage 1 can't be true and stage 2 is true because we reset stage 1. And stage 1 can't be true because, or those types of things. So it becomes a very sequential. A has to happen, then B, then C, then D. All right, and we actually can do this. I can switch this programming ladder to be structured. Let's just here. Ready? Add a new block, and we can actually do a structured language here. So you could go like actually do normal programming language with this, which I've never done, which is kind of interesting. That's not what I want. If photo, no, goods, there we go. Then you would say, I don't know how you do an output, I'm not gonna lie. Again, I've never really done it this way. Do I just say motor forward? Conveyor. Yeah, I need something before this. Probably a set. Nope. Oh, do we need a? Yeah, no, I don't know. I've never done this language, so. But yeah, this becomes very sequential is all it comes down to. So great way to kind of keep your mind focused on the process. All right. I'll be very interested to see how this helps you, how this type of programming helps you out in the future of this class. So